Hello children, Ragini ma'am here. Today I am here to explain you chapter 4, that is heat. Before that, I just want to ask you whether you have completed your work of chapter 1 and chapter 3 or not. Dear students, please complete that work and also share the doubts in comment box. So children, get ready for a new chapter. It is very interesting chapter. Lot of activities are there in the chapter which you can perform at home. So get ready. The chapter name is heat. Now, first of all, what is heat? Heat is a form of energy which causes sensation of hotness and coolness. Its SI unit is what? Its SI unit is joule, and non-SI units are calorie or kilocalorie. And children, 1 calorie is equal to 4.184 joules. Now, when we are talking about heat, we should know that the meaning of hot and cold. Sometimes we touch hot tea and we say that, oh, it's very hot. And then sometimes when we touch ice, we say, oh, it's very cold. So we can understand if an object is hot or cold by the sense of touch. We can say that, oh, it's very hot, it's very cold. However, it can trick us sometimes. How? Because we cannot say sometimes cold water from the fridge, we have taken out cold water from the fridge, and ice also we have taken out, and we are touching both the things, but we cannot find out that which one is more hotter than which one is more hotter. So to find out the relative difference between that in their temperature, we use what? An instrument called thermometer. Now, this thermometer is used to measure the temperature of an object. Now, what is the temperature? It is the degree of hotness or coldness of an object. And SI unit of temperature is what? Kelvin. And commonly used units of temperatures are what? Celsius and Fahrenheit. Generally, what we are saying that today's temperature is 26 degrees Celsius or 25 degrees Celsius. Now, the instrument which we use to measure temperature is called what? Thermometer. So here the definition is what? It is a device that can be used to find out how hot an object is, how hot or cold an object is. In other words, we use a thermometer to measure the temperature of an object. Now, when we measure the temperature of an object, there are two kinds of thermometers which we use to measure the temperature of an object or a human being. So first is which one? Clinical thermometer. Clinical thermometer is also called what? Doctor's thermometer. And this is the diagram, this is the picture of that clinical thermometer. You can see that kink here, graduated scale which is ranging from 35 to 42 degrees Celsius, and it is a uniform glass tube. Here it's the description how to explain this Celsius thermometer. It is a device that is used to measure the body temperature of a person. You must have seen your parents or doctors, they put this clinical thermometer into your mouth, under the tongue of your mouth, or sometimes under the armpit to measure the temperature of your body. It is made up of a glass tube of uniform thickness. The glass tube contains a bulb at one end which is filled with mercury. This is bulb, children, which it is filled with mercury. The mercury level in the thermometer rises up in the thread-like portion of the thermometer. Can you see this thread-like portion? This is called thread-like portion of a thermometer, where this mercury level rises when it is when it got heat, and due to that mercury expands, and then it rises in this thread-like structure to give to indicate the temperature of the body. The level of the mercury can be measured by reading the scale given on the thermometer. The scale of the thermometer records the temperature in degrees Celsius, and it is generally from 35 degrees Celsius to 45 degrees Celsius, which is the range of human body temperature. On an average, the normal temperature of human body is what? 37 degrees Celsius. The clinical thermometer has a small sharp curve which is called what? Kink. Can you see this kink? Here it is a kink. And why it is present, and it is present near the bulb, and why it is present in clinical thermometer? It prevents the mercury level from falling down on its own in the thermometer. So why it pushes the when the mercury expands, it pushes through the kink, but when it is taken out of the patient's mouth, mercury does not go back to the bulb, so the doctors can read the patient temperature easily. That is why it is very useful, and that is why this kink is present in clinical thermometer. Now, how to use the clinical thermometer? Firstly, wash the thermometer with an antiseptic solution, because the doctors are keeping them in patient's mouth and or patient's armpit. So due to that, we should wash the thermometer with an antiseptic solution. Secondly, before taking the temperature of the thermometer, is given a few jerks to bring down the level of the mercury below 35 degrees Celsius, so that the accurate temperature can be taken. Then the thermometer is placed beneath the tongue for about a minute. Then you can take it out and observe the temperature reading on the thermometer. Now, there are some precautions which should be taken while using a clinical thermometer, and these precautions are what? Wash the thermometer before and after using it. Before also with an antiseptic solution, and after also, because it is very important part. Now, make sure the temperature of the thermometer is below 35 degrees Celsius before taking the temperature to get the accurate temperature of the patient. Keep the thermometer straight in order to see the mercury level precisely. Otherwise, what will happen? You will not be able to get the accurate temperature. It should always be held with care, or it can break down, because it is made up of glass. You should not touch the bulb of the thermometer at all. Otherwise, that due to the heat of your fingers, again the mercury level will expand, and again the temperature will not be taken accurately of the patient. Now, the second thermometer is which one? Laboratory thermometer. Now, see, you can see the diagram of laboratory thermometer. Here, the thermometer is same like clinical thermometer, but what is extra in this? That the scale is very long. It is not from 35 degrees Celsius to 45 degrees Celsius. It is from minus 10 degrees Celsius to 110 degrees Celsius. Then you will find one more change in this, that there is no kink present in it, because the laboratory thermometers are used in labs to find out the temperature of chemicals and all. So they are capped in the chemical, and it's not necessary to take out that from the chemical to measure, to get the temperature. So it is while keeping that into the chemical only, we can measure the temperature of that chemical. That is why the kink is not present in laboratory thermometer. The laboratory thermometer is used to find out the temperature of other objects such as water, rather than human body temperature. It can measure the temperature from minus 10 degrees Celsius to 110 degrees Celsius. Now, some precautions we should take while using a laboratory thermometer also. So what is the first precaution? You should always follow the same precaution as that of clinical thermometer. Secondly, you should always hold the laboratory thermometer in a straight upright position without tilting it. This word is what, children? Tilting. So why again it is necessary? Because otherwise again the temperature will come something wrong, and you will not get the accurate temperature of that chemical. The bulb of the thermometer should never touch the surface of the container. Why it is why we should not touch the bulb of the thermometer to the container? Because again the bulb is filled with mercury, and as soon as it touches the surface of the container, it takes the temperature of that container also, and mercury level will expand, and again it will not give the accurate temperature of the chemical. So that is why we should the bulb of the thermometer should never touch the surface of the container in which the substance is capped. Now the last one is what? The bulb of the thermometer should be completely immersed in the substance. It should be completely dipped in the substance to get the temperature correctly, so that it covers the bulb from all the sides. Now there are so many other types of thermometers are also there. One is minimum and maximum thermometer. It is a thermometer used to measure the minimum and maximum temperature of the day by weather forecasters. So this kind of thermometer is used by whom? Weather forecasters, to get the minimum and maximum temperature of the day. It looks like this, children. Then nowadays we are not using those mercury thermometer, because they are we have to be very careful while using that mercury thermometer. So nowadays a digital thermometer came in origin. It does not break, and it is a digital thermometer, and it is not made up of mercury also. So what is digital thermometer actually? It is sometimes difficult to handle a mercury filled thermometer, especially when it breaks and mercury falls out. And you know that mercury is so it is a very toxic liquid. So when it comes out from the thermometer, and sometimes if we'll touch it, and if that goes in our mouth or something would happen, the fumes are also very toxic. So it is very dangerous when that clinical thermometer or laboratory thermometer breaks. So nowadays digital thermometers are available to use. This type of thermometer does not contain mercury. It directly displays the correct temperature on a display screen. Have you seen this kind of digital thermometer, children? Now the main portion of this chapter has come. That is what? Transfer of heat. Do you know that heat also transfer from one object to another? Have you seen sometimes when we are boiling a water in a pan, and one spoon is kept inside that pan? Afterwards when you touch that, the spoon becomes very hot and you are not able to touch that spoon. This is what? This is transfer of heat. Now transfer of heat is also taken by three ways. The one is what? Conduction. Second one is what? Convection. And third one is what? Radiation. So first of all we are discussing what? Conduction. Now this type of flow of heat, now flow of heat is always from hot to cold side. It never occurs from colder side to hotter side. So it always flows from, the heat always flows from hotter object to colder side, colder object. The flow of heat always takes place from a hot object to cold object. It occurs by conduction. First process is what? Conduction. The process of flow of heat from an hot object to a cold object, which occurs only in solids without the movement of material as a whole, is called conduction. So here that material do not move from its place, but just due to heating, when we heat an object, the particles which are present in solid, they on their own place they vibrate and they produces some energy. Due to that, the other particles of the solid again starts vibrating, and this way the heat flows from hotter side to colder side. And this flow of heat from hotter object to a colder object in solids is called conduction. So here that diagram is given. When we heat a you can say steel rod or iron rod from one side, slowly it will see that red color. It will the heat, this portion will heat first, then slowly the particles will vibrate inside that solid because they are very closely packed. So when the particles of the solids are very closely packed, so one by one all the particles they vibrate on their place, and then due to that some energy is produced which flows from a hot object towards the colder object and starts vibrating, and slowly after some time the other end of that metallic rod will also become also will heat it up. This type of process is called conduction, and this occurs This occurs, some objects can conduct heat. Now in some objects only it can conduct heat, some objects do not conduct heat. In solids also some objects only conduct heat while others cannot. The objects which conduct heat are called what? They are called conductors. So the objects that can allow the heat to flow through them are called conductors. For example, metals such as copper and aluminium. So these are what? These are conductors. While the objects which do not allow the flow of heat from them are called insulators, like wood and plastic. These are insulators. Now when we heat a pan also, then what happens? We can hold it from this side because this is made up of a plastic, while the pan is made up of a metal, so it will heat it up. But when we hold it from that the side of the pan, the handle of the pan, that will not heat it up, that is not hot, and we can handle it very easily. Now the second way of transfer of heat is convection. Now what is convection? The transfer of heat in liquids and gases, not in solids. The transfer of heat in liquids and gases by the movement of itself is called convection. It does not occur in solids because in liquids and gases, the molecules of these liquids and gases are very loosely capped. So transfer of heat is possible by the movement of itself, that one molecule moves from its place to another molecule, passes the heat, and this form is called convection. So here is the process given. The molecules of the liquid or gases that are near the source of heat get heated first. They become lighter due to the heat and move upwards. The colder particles, being heavier, take the place, and this process continue until the whole liquid or the gas gets heated. That is why the area above the flame of a candle always feels hot, but the area on the sides of the candle does not. This is the process of convection. See, the area above this, the liquid above the gas flame, it heated up first, it flow because it becomes lighter, it flows up, then the colder liquid will come down, again it becomes hot, and this way that a cycle is formed. And this convection cycle, due to this convection cycle, the whole liquid or the gas gets heated, and these are called convection currents. Now the next is, third one is what? Radiation. It is the process of transfer of heat in the form of waves or radiations. There is no medium present in it. There is without medium, there is a transfer of heat in the form of waves or radiation. That is called what? Radiation. So there is no medium present in the radiation. The sun's heat reaches the earth's surface through radiation, because between the sun and earth there is a vacuum. So in the vacuum also, the heat of the sun reaches the earth's surface, and that due to what? Due to wave in the form of waves or in the form of infrared radiations. So these radiations that is the third process by which the heat transfers. Every hot object radiates some heat into the environment. Hence, many times an object gets heated just by being near to a hot object. This is an example of radiation. Fire is burning, and when you are putting a hand over it, through the radiation only, your hands becomes warmer. There is no medium present between it. Now, coming on to the sea breeze and land breeze. Now, sea breeze and land breeze also occurs due to the temperature variations. It is also occurs due to the variation in, you can say, temperature, that means heat. Now, this is sea breeze. Now, in sea breeze, what happened? The breeze which flows from sea to land is called sea breeze. So, the wind blowing from sea towards the land is called sea breeze. Now, what happened during the daytime? The land in the coastal area gets heated due to sun's radiation. coastal area, the land in the coastal areas gets heated due to what? Sun's radiation. And you know that between water is also heated up and land is also heated up, but the land heated little faster than the water. The sea also gets heated, however it takes more time to get heated up than the land. So the land heated faster than the sea. Hence the air above the lands get heated faster than the air above the sea. So as soon as the land gets heated up, the air above the land is also heated up faster than the air above the sea. So as soon as the air heated up, it becomes warm and it becomes light, and the light air always goes up. Hence the air above the lands get heated faster than the air above the sea. The hot air from the land rises above as it is lighter, and the cool air from the sea as it is heavier takes its place, and this results in the sea breeze. Now next is which one? Land breeze. Now land breeze is also the same way it occurs, but it occurs during night time. When you can see moon here, it occurs during night time. What happened? As soon as the temperature becomes low during night, what happened? The wind from here the wind are blowing from land towards the sea. That is why it is called land breeze. During the night time, the land in the coastal areas gets cool down faster than the sea. Again the land will cool down faster than the sea. Firstly, the land is becoming hotter than the sea. Faster it becomes very fast. It heated up very fast, while the air above the sea, it will a little slower, it works a little slower. So during the night time, the land in the coastal areas gets cooled down faster than the sea. The air above the sea is hotter than the air above the land. Therefore the air above the sea rises up, and the air from the land, being cool, flows towards the sea, and this breeze which flows from land to sea is called land breeze, and it occurs during night time. Now there are some questions which you have to some question answers to I have given, and some questions you have to do. Here the chapter is ending on this land breeze only, but now there is a question: why do we wear light colored clothes in summer? Why do we wear light color clothes in summer? The light color clothes reflect the heat back into the environment and keep us cool during the summer time. That is why we wear light color clothes in summer. Now, why do we wear dark colored clothes in winter? The dark color clothes absorb the heat from the environment and keep us warm. That is why we wear dark color clothes in winter. Now, how do woolen clothes keep us warm? As we know, woolen clothes are bad conductors of heat. Therefore, they do not allow the heat from the body to move out in the environment. The woolen clothes means I'm talking about wool. The sweater is made up of the wool, and wools have some holes inside it which trap what? Air inside them. As a result, the air present between the woolen clothes and our body becomes hot, and this makes us feel warm. Now similarly, one more thing, two thin blankets provide more heat than a thick blanket, because air can be trapped between the two thin blankets. So always we should have two thin blankets which provides more heat than one thick blanket. Now there is a conversion. Now these are the numericals you have to do, children. One I have shown you, the rest you have to do yourself. Now conversion, Fahrenheit to Celsius. Now Fahrenheit to Celsius, there is a formula because in the Fahrenheit scale there are 180 partitions in a thermometer scale, while in the Celsius there are just 100 divisions are there in Celsius scale, while there are 180 divisions in Fahrenheit scale. So therefore the formula becomes what? That Celsius is equal to 5/9 and in the bracket F minus 32. So and here you have to use always BODMAS rule. First you have to divide, then then multiply, then you have to do whatever the BODMAS rule. What is the BODMAS rule? First you have to solve the bracket, then you have to solve the off, then you have to solve the division, then you have to solve the multiplication, then you have to solve the addition, and then you have to solve the subtraction. So BODMAS rule you have to use here. So first you have to solve the bracket, then you have to solve the off if there is any off, or then you have to solve the division. Now Celsius to Fahrenheit, what is the formula? F is equal to 9/5C plus 32. So again here there is no bracket, so it does not mean that C plus 32 you can do first. No, first you have to solve division, then multiplication, then addition, and then subtraction. So now first one I have shown you, like convert 15 degrees Celsius to Fahrenheit. Now Celsius is given, you have to convert that into Fahrenheit. So which formula you have to use? That Fahrenheit is equal to 9/5C plus 32. So Fahrenheit you have to find out. So Fahrenheit is equal to 9/5C plus 32. So on the place of C, what we have to put? We have to put the value, and the value of C is given what? 15 degree. So 9/5 multiplied by 15 plus 32. Now when we this is upon 5, so dividing, so 5 the 15 will cut by 5 and it will come 3. So 9 into 3 plus 32, that is 27 plus 32, that is 59 degree Fahrenheit. So we can say that 15 degrees Celsius is equal to 59 degree Fahrenheit. Now there are some questions for you. Do these in your rough notebook also. Convert our normal, you can do this in your rough notebook. Convert our normal body temperature to degree Fahrenheit, and normal body temperature of our body is what? 37 degrees Celsius. So convert this into degree Fahrenheit and find out the answer, and give me an answer in comment box. Convert freezing point of water to degree Fahrenheit. Freezing point of water is what? 0 degree Celsius. So convert that 0 degree Celsius into degree Fahrenheit. Now you have to find out which formula you have to use. You have to convert that into Fahrenheit. So Fahrenheit and Fahrenheit, so same formula, F is equal to 9/5C plus 32. Now third question, why does ice is covered with jute cloth or sawdust? Now find out about this jute cloth and sawdust, and why we are keeping those ice in jute cloth or sawdust. Now find out the answer and give me the answer in that comment box only. Why does the heat transfer by convection possible only in liquids and gases? Why the heat transfer by convection is possible only in liquid and gases, not in solids? So these are some questions, children, which you have to answer. So here that's all, children. This chapter is over here. Please do some of the activities related with the heat and temperature, like you can check the temperature of your parents, normal body temperature also, and sometimes you can take the temperature of tea also. You can take the temperature of ice cold water also. So find out the temperature and just understand that how we measure the temperature, how we find out the temperature of a human being, how we find out the temperature of a chemical and all. Then find out some hot and hotter and cold. Why do we call some cold and hot? And so some activities are there regarding all these activities you have to do. Then please go through with the video twice or thrice so that it becomes easy to understand the chapter. As chapter is lengthy, so we'll send exercises in next week. So children, just enjoy and just chill. So bye bye. Have a nice time. God bless you all.